Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is AQA June 2020, Paper 2, Foundation Tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Welcome along to another past paper walkthrough. Today we're going to go through June 2020, Paper 2, Foundation Tier, calculator paper. Strangely, it's listed on the AQA website as November 2020 if you tried to find a hard copy of the paper, but on the front of the paper it's definitely marked June. Let's get cracking. Question 1, circle the ratio that is the same as 3 to 4. Okay, so you can find equivalent ratios very similar to what you would do with fractions. With fractions, you would just multiply top and bottom by a same number. So if I multiply top and bottom by 2, it's going to give me a similar fraction. So that would give me 6 over 8. And we can do the same thing with ratios. We can take a number and multiply it through by the same number on both sides. And it's going to give me an equivalent ratio. So, which is that one there, look. Okay, so we found it. Question 2, it says circle the size of angle X. Now, angle X is here, and what we've got here is angles meeting at a point, haven't we? So those three angles, X, 50 and 60, all meet at that point there. Okay, now angles meeting at a point always sum to 360 degrees. So if I take the three angles, X and 50 and 60, and add them together, it's going to give me 360. Okay, well, I know that 50 and 60 together is 110. So my X plus 110 is 360 degrees. And then taking 110 away from both sides will just leave me with X then, won't it? So that's going to cancel with that. It's going to leave me with X equals 360, take away 110. That's 250 degrees. So it's going to be that one. Question 3, circle the expression that has the smallest value when X is equal to 4. So I think what we're going to have to do, we're going to have to evaluate each of these, aren't we, and then work out what they are. So we're going to sub 4 in wherever you see X in each of these expressions and work out what we've got. So the first expression, 5 minus X, so if X is 4, then I've got 5 minus 4 there, haven't I? And 5 minus 4 is equal to 1. Okay, now the next one, half of X is going to be half of 4. Now multiplying by half is the same as dividing by 2, so it's going to be 2. X plus 1, that's going to be 4 plus 1, so that's 5. And X take away 4, well, X is 4, so 4 take away 4, that's equal to 0. So which one of those is the smallest? Well, it's that one there, isn't it? It's the one that gives me 0. That's the smallest value I get. Okay. Question 4, the term-to-term rule for a sequence is add 1 and then double. The first two terms are 2 and 6. Circle the next term. Okay, so a term-to-term rule tells you how to find the next term from the previous one. So we're told that the first term is 2. I'm just going to use this to demonstrate. So if I take 2 and I add 1 to it and then I double it, so 2 add 1 is 3, and then doubled is 6, isn't it? So that gives me the second term 6, which I was already given down here anyway. Okay, but it's always a good idea just to use the ones you've been given, just to make sure you're clear about how the rule works. And then after that, then we're going to just carry on. So the next term in the sequence is going to be 6, add 1, so 6 plus 1, and then doubled. So 6 plus 1 is 7, and then 7 times 2. That's going to be 14 then, isn't it? So my next term there is going to be 14. Question 5a, solve 7x equals 56. Now I want to solve something. That means get x by itself, work out the value of x. At the moment I've got 7x. If I want to find x from 7x, I need to divide by 7. And with equations, if you do something to one side, you have to do the same thing to the other side, otherwise it doesn't stay balanced. So my 7 and that 7 there are going to cancel out, leaving me with x on the left, and then 56 divided by 7, well, that's 8, isn't it? So x is equal to 8. Now part B says solve 25 minus y is equal to 18. Okay. Now I want to get y by itself, but I'm thinking if I take 25 away from here, then I'm going to be left with minus y, which is it's not the best thing. It's gonna make my life a little bit more complicated. So just to make my life easy, first of all I'm going to add y to both sides. You might not immediately see the reason for that, but it'll become apparent in a second. So that y there is going to cancel with that one. It's going to leave me with 25 on the left, and I'm going to get 18 plus y on the right. Now you notice now I've got a positive y and not a negative one, so that just makes things a little bit more simple. Okay. Now finally, just to get to get y by itself, I'm going to take 18 away from there. And if I take 18 away from there, I've got to do it from there as well. Now they're going to cancel, and it's going to leave me with y on the right, and then 25 take away 18. That's going to give me 7. So I've got 7 equals y, and that is exactly the same. You can just flip those around and say, well, y is equal to 7 then. Okay. So if the thing that you want to find starts off being negative, then the easiest thing, like I say, is just to flip it over to the other side of the equation by adding it to both sides to start with straight away. And you can see it just immediately jumped over and became a positive y there in the end, which makes life a little bit more simple. Question 6, 11 people play a game. Here are their scores. So I've got a list of different scores. I've got 12, 9, 15, 9, 18, 18, 3, 14, 9, 16 and 20. Now I need to write down the mode. Now mode is a type of average, and it's the most frequently occurring value, isn't it? So scanning through that list, I can see I've got a number of 9s. I've got multiple 18s. Is there any more that are duplicates? No, the rest are all just single occurrences, isn't there? So I've got 2 18s, but I've got 3 9s. So 9 is going to be the mode. Mode is most. Most frequently occurring is 9. Now, median is another type of average. It's the middle number, isn't it? The median. But it's the middle number after we arrange it from smallest to biggest. So the first thing you're going to do here, and the thing that's going to get you the first mark, is to take that list of numbers and rewrite it from smallest to biggest. Okay, so just scanning through there, I can see 3 is my smallest number. Then what's next? Is it the 9s already? Yeah, then it's the 9s. I've got 3 of those. So 3, 9, 9, 9. Then what? I've got a 12, 14, a 15, a 16, 2 18s, and a 20. Okay, so I'm just checking I've got the same number of numbers I had to start with, because it's easy to lose one when you're rearranging. That's why I kind of wrote it underneath the original one, so I'm kind of checking I've got the same number of numbers at the end. Right, now I've got them all, I can work out what the middle one is. Now, if we've got an odd or even number of numbers here, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. Okay, so the middle number, you take your number of numbers, you add 1, and then you divide by 2. And that's where the median is. Okay, so if I got 11 and add 1, I'm going to get 12, and divide by 2, it's going to be the 6th number in my sequence. Okay, so just counting through from either end, 1, 2, 3, 4, 5, 6, then that median there is going to be 14. Okay, 14. Question 7 says line AB is shown where A is the point 10 and B is the point 58. You can see that drawn on the diagram there. Part A says P is a point on AB. The distance of AP is half the distance of AB. Okay, so basically what we need to do is find the midpoint of that line. Okay, now you can see to get from A to B, you have to go 1, 2, 3, 4 units along, and you go 1, 2, 3, 4, 5, 6, 7, 8 up. Okay, so to find the midpoint, all you got to do is halve those distances. So rather than going 4 along, we're going to go 1, 2 along, and rather than going 8 up, we're going to go 1, 2, 3, 4 up. So you can see, well, you should be able to see that the midpoint there is that point there. Okay, so that is the coordinate 3, 4, isn't it? 3, 4. So that's what we're going to write down here. 3, 4. Okay, and then part B says a line is drawn from B that is parallel to the x-axis and meets the y-axis at the point Q. Work out the coordinates of Q. So a line is drawn from B. Where's B? B is here, and it's parallel to the x-axis. Okay, well, the x-axis is this line down here, so it's got to be parallel to that line there and passing through B. So it's going to be, running out of colours, let's just go green again. I'll do it dotty. Okay, so yeah, there's my line parallel to the x-axis running through B. Okay, so where does it meet the y-axis? It meets the y-axis here, doesn't it? So this is going to be my point Q. So that was my point P. This is my point Q. And what's the coordinates of that point? It is 0 in the direction of x and 8 in the direction of y. So it's going to be 0, 8. 0, 8. Question 8a. Write down an even whole number that is also a square number. Okay, so we want a number that's a square number, an even number, and a whole number. Okay, so even numbers are like our numbers 2, 4, 6, 8, 12. Whole numbers means they don't have any decimal or fraction parts, so just like a single, like a whole unit. And square numbers are numbers that you can get by multiplying a whole number by itself. So 1 squared is 1, 2 squared is 4, 3 squared is 9. So the square numbers are 1, 4, 9, 16, and so on. So you could have any of the even ones of those. So every other number is even, isn't it? So the even squares are going to be like 4, 16. And I could have had 6 squared is 36 as well. So any of those, you can have any of those. It doesn't have to be one particular one. I'm going to pick 4. B, write down all the cube numbers between 100 and 400. So the cube numbers you get by multiplying a whole number by itself 3 times. So like 2 cubed, 2 times 2 times 2 is 8. But obviously 8 is not big enough. It needs to be between 100 and 400. But cube numbers get big very quickly. So 3 cubed, 3 times 3 times 3 is 27. 4 cubed, 4 times 4 times 4, that's 64 already. 5 cubed, 5 times 5 times 5, that's 125. You can do this on your calculator. No point in stressing. It's paper 2, it's the calculated paper. So the first one is 125. What's 6 cubed? 6 times 6 times 6 is 216. You have got a kind of a handy cube button on your calculator. So 7 cubed, 343. 8 cubed, 8 to the power of 3, 512. So that one's already too big, so it's those 3. Okay, so I just got 3 to write down. 125, 216, and 343. Let me just double check. And part C says write down two numbers that are multiples of 3 and multiply to make 216. Okay, so I want two numbers that are each of them are multiples of 3, so they're in the 3 times table, and they multiply together to give us 216. Now you remember that 6 times 6 times 6 was 216, wasn't it? Because we just did it. So 6 cubed is equal to 216. And 6 cubed is 6 times 6 times 6. So what about if we just kind of multiply those two together and say 36 times 6? That's going to be equal to 216, aren't they? So these are two numbers that multiply together to give me 216. And because 6 I know is a multiple of 3. 3 times 2 is 6, and 36 is a multiple of 3, isn't it? It's 12 times 3. So those two work. So I'm just going to use those. I'm going to use 36 and 6. Now there are others. Are there others? Maybe there are others. I'm not sure. I think there might be. But I found one. I'm not going to bother to search for the others. Question 9. Members of a club are senior, adult or junior. Here is a report about members of the club. So 18% are senior, 54% are adult, and 38% are junior. Give a reason why there must be a mistake in the report. Okay. Well, I'm thinking it's probably got something to do with percentages. So let's just add up these percentages together. What do we get if I add those up? Mr. Calculator, what is 18 plus 54 plus 38? Look at that, adds up to 110. That's no good, is it? Percentages need to be out of 100. These add up to 110. So can't possibly be right. Okay, so total sums to 110%. It should be 100%. Okay, so that's the mistake, isn't it? That's why it must be wrong. And part B says an adult membership fee is £120. A junior membership fee is 1/5 of the adult fee. Work out the total membership fee of 2 adults and 3 juniors. Okay, so what's 1/5 of 120 then? So 120 divided by 5, according to my calculator, 120 divided by 5, that comes to £24. So the child rate is 24 and the adult rate is 120, and we've got 2 adults plus 3, well I called them child but this says juniors here. Let's just make that junior. Okay, and so we need 2 lots of 120 then and 3 lots of 24, and just type that straight into the calculator. So 2 times 120 plus 3 times 24. If you've got a decent calculator, it will know BidMaths, so it will know when to do the adding and the multiplying. That comes to 312. Okay, so that's the total then. The total membership fee for 2 adults and 3 juniors is going to be £312. Question 10a. Here is a number machine. I've got an input and then it's multiplied by 4 and then 9 is added and I get my output. It says work out the output when the input is 16. So if I put 16 in at this end, what happens? Okay, so first off it kind of trundles through to here, doesn't it, where it's multiplied by 4. So 16 times 4, double 16 is 32, double again is 64. So 64 is going to pop out there, isn't it, in between. Okay, so then my 64 is going to trundle along into the next box where 9 is added to it. 64 plus 9, that comes out to number 73. Okay, so that's my answer, 73. Right, part B, here is a different number machine. Work out the output where the input is negative 48. So I'm going to put negative 48 in here this time. Negative 48. So negative 48 plus 6. Okay, so if you're on the number line at negative 48 and you add on 6, you're getting more positive, which is less negative. So 48 47, 46, 45, 44, 43, 42. It's going to be minus 42 that pops out there. So my minus 48 is trundled through here. I've had 6 added, it's got to come to minus 42, and then it's going to trundle on to the next part of the machine, which is divide by 2. So negative 42 divided by 2. Well, 42 divided by 2 is 21, so negative 42 divided by 2 is negative 21, isn't it? So I get negative 21 as my output. Finally, part C says complete this number machine. Now 5 has gone in. Something happens to it, which we don't know, mystery thing, and then 10 is taken away and we got 5. Okay, so we're going to have to kind of come at this from both directions. Okay, so I'm going to kind of work back from the 5 first of all. So if I had a number and I took away 10 and I got 5, then kind of if I want to leapfrog back over this way, I'm going to have to do the opposite of that minus in 10 on. I'm going to have to add 10. So 5 plus 10 is 15. Should be 15 there. Okay, if you think about it, 15 take away 10 is 5. So that's good. Now coming back from the other way, if I then start from the 5 and I think now what do I have to multiply 5 by to get 15? Well, I think you'll see that the answer there must be a 3. Okay, so I've completed it. I had to put the 3 in. That's the thing I needed to do to complete it. So my kind of arrow, my 15 thing was just working. It's the 3 that I needed to put in. Right, here are 2 calculations. I've got 17 squared minus 300, and I've got 47 times 21 minus 10 cubed. Which calculation has the smaller answer? You must show the answer to each calculation. Well, it's really simple to do, isn't it? This is a calculator paper. I just need to type it in. Now, again, like I said before, if you've got a decent calculator, you should understand the rules for big maths. So I don't have to do any thinking. Just got to type it in exactly as it is on the page. So 17 squared minus 300. Oh, calculator, what is that? That is minus 11. So that one is equal to negative 11 there. And then I've got 47 times 21. 47 times 21. Minus 10 cubed. So typing that in exactly the same. Yeah, it's the same. Press enter. That one comes out to be negative 13. Okay, so which calculation is the smaller number? Well, the smallest is the most negative, isn't it? It's going to be that negative 13. So that is my answer. It's negative 13. Question 12. Match each expression on the left with one on the right. One has been done for you. Looks like they did the hard one for us, so that's nice. So we just got like the easier ones to do now. So let's do it then. A plus A plus A plus A. Well, A plus A plus A plus A is just 4A, isn't it? So that one there must link with that one down there. 4 times A times B. Well, nothing really to do that other than to say, well, that's 4AB then, isn't it? In a kind of more succinct way of drawing these, or sort of writing these as in algebraic form, so it should be going there. A times A times A times A. When you multiply something by itself, you raise it to a power, don't you? So A times A times A times A is A to the power of 4. And finally, A plus B plus B, collecting like terms together, my A plus A is going to be 2A, and my B plus B is 2B, so I'm going to end up with 2A plus 2B. Okay, so that all went rather well. Question 13. Jenny works for 30 hours and is paid £318. Calvin works for 28 hours and he is paid £287. Jenny is paid more per hour than Calvin. How much more? Well, let's find out. So let's do Jenny first. Jenny. Right, so she works 30 hours and she's paid £318. So her hourly rate is going to be her total pay, which is 318, divided by her number of hours, which is 30. Okay, so on my calculator, 318 divided by 30, well, that comes out to be 10.6. Remember, this is money, so that's going to be £10 and 60 pence, isn't it? Not 0.6. Have to write it in pounds and pence. And now let's do Calvin next. So what about you, Calvin? So his hourly rate then is £287. He earned less, but he worked less hours, didn't he? He only did 28 hours. So what does that come out to be then? So 287 divided by 28. That'd be £10 and 25 pence. It's not a great deal of difference, but I suppose it adds up over the months. So 10.25. Okay, so have we answered the question? No, because the question is how much more does Jenny earn? So the last thing we need to do here really is a subtraction, don't we? So we need to do a subtraction. So 10 take away £10.60, take away £10.25. What's that? So £10.60 minus answer, that comes out to be 35 pence. Okay, so that's £0.35 or 35 pence. It was pence down here. Just make sure you match the units. So it's 35 pence. Question 14. This circle has centre C. W, X and Y are points on the circle. WY is a straight line. Just having a look at this. W, C and Y all lie on a straight line. C is the centre of the circle. So that makes this line a diameter. These two lines are chords. This shaded part here is what we call a segment. So let's see if we can answer the questions. Right, is WY a diameter? Yes, it is. I just answered that, didn't I? Okay, because the line goes through C, the center, must be a diameter. WX is the radius. That is not right. The radius would be WC. The shaded section is a sector. No. A sector is like that. That's a sector. This one, so a sector is made up of part of a curved surface of the circle plus two radii. That's a sector. Now a segment is made up from the curved part of a chord. Okay, so it's a bit like an orange segment, isn't it? So that's what a segment is. So we've got a segment here, not a sector. So that's wrong there. And then arc XY is part of the circumference. Arc XY. This. Yes, that's a bit of the circumference, isn't it? It's like a little snippet of it. So that is true. Okay, so we agree with that one. Okay, so true, false, false, true. Question 15. Mortar is made by mixing cement and sand as shown. For every 1 kilogram of cement used, add 4 kilograms of sand. Okay, so mortar, if you didn't know, is the kind of stuff that is in between the bricks, holds the bricks together when you're building a house. So it's that bit in the middle. Okay, so cement costs 19 pence per kilogram and sand costs 7 pence per kilogram. Thomas uses 150 kilograms of cement to make some mortar. Work out the cost of the mortar. Okay. So he needs 150 kilograms of cement. So let's start there. So we know that cement costs 19 pence per kilogram. So the cement costs, that is going to be the 150 kilograms times the cost per kilogram, which is 0.19. So that comes out to be 150 times 0.19. That comes out to be £28.50. Okay, and what about the sand? Well, we know that for every 1 kilogram of cement that we use, we need to use 4 kilograms of sand. So if I take 150 and I times it by 4, I'm going to get 600. I'm going to need 600 kilograms of sand, aren't I? So the sand costs, well, we're going to need 600 kilograms of it, and it costs 0.07 pounds per kilogram. So 600 times by 0.07, that comes out to be 42 pounds. Okay, so then the total cost of the mortar then is going to just be those two added together, then, isn't it? So I'm going to add on my last answer, £28.50. So that comes out to be £70.50. That's my answer. Okay. So mortar, just gonna spell it out. Costs £70.50. So the exam doesn't have to go and search for my answer. Written it down nice and clearly. Okay. Question 16a. Here is a shape made of rectangles, and we need to work out its area. So area is the space inside the shape, and I've got a compound shape made up of two rectangles pushed together. So to work out its area, the first thing I'm going to have to do is to divide up. Okay, I need to divide up into two separate rectangles. Now, the ruler happened to be that way around, so I've divided it that way. I could have divided it that way, it wouldn't have made any difference. It would have still come out to be the same answer. Okay, so what is the area of that first rectangle? Well, it's 9 by 2. So its area, or area 1 for the smaller one, is going to be 9 times 2. That's 18 cubic squared centimeters. Now area 2 down here, what is this distance here? Now it's got an 8 written next to it, but that is the distance all the way down from here down to there. Now I've only got this, I've got this shorter bit, haven't I? I've got a bit taken off. So if you remember, this bit over here was 2, so this bit over here is 2 as well, isn't it? So if I take 2 away from the 8, then this bit down here is actually 6. Okay, so I made a bit of a mess of that. Let me just tidy it up a little bit. So this bit down here, the blue section there, is 6. Across is 4, so the area of this smaller rectangle is 6 times 4. That's actually larger. 6 times 4 is 24. Looks smaller. It's larger. So the total area is going to be my area 1 plus my area 2, which is 18. Not writing very neatly, am I? 18 plus 24, which is 24, 34, 42. 42 what? Centimeters squared. So 42 centimeters squared. Part B says Zach wants to work out the area of this triangle. So we've got a triangle here. I've got various measurements on it, and he says here is this working. The area of the triangle is 12 times 8, which is 96 centimeters squared. Okay, well, he's been a bit of a muppet, hasn't he? Because he's used the area formula for a rectangle. Now, we just used area equals length times width to work out the area of our rectangle a minute ago, didn't we? But a triangle is half a rectangle. So when you're working out the area of a triangle, it's got a different formula. The area of a triangle, we say, is a half base times height. So this is the base, this is the height, isn't it? Okay. So if I'm working out area as a half base times height, then where's my base? Here's my base, it's 12. Where's my height? Here's my height, it's 8. So the area should be a half times 12 times 8, which is 6 times 8, it's 48. 48 centimeters squared. Now it's probably overkill. It was only 1 mark. I should have just said he used the rectangle formula, not the area formula. But anyway, it's done now. Question 17. Here are some shapes, P, Q, and R. Yes, there are. Part A says P is mapped onto Q by a single transformation. Circle the type of transformation. Okay, so P is going to Q, isn't it? So here's P up here, here's Q down here, and you can probably see it's a reflection, can't you? Okay, so if I draw a mirror line in, the mirror line is going to be halfway between them, isn't it? So that's like 1, 2, 3, 4, 5, 6 squares in between, so the mirror line is going to be 3 in between them, so like the mirror line is going to be here. Again, I'm kind of doing more work than I need to. There's my mirror line. So it's a reflection, isn't it, basically? I just wanted to show that it was a reflection. It's that one. Part B says P is mapped onto R using a single transformation. Okay, so we've got P up there, and then R is this one down here, isn't it? Okay, so how's it going to get from there to there? Well, it's not a reflection, is it? I mean, even if we had the mirror line here, can you see that the shapes would be the other way around if that was the mirror line? So I don't think it's a reflection. It's not a translation because it's changed its orientation. It's not an enlargement. So that only really leaves a rotation by an order of elimination, and actually I can see that's probably the case. Question 18. Kim buys pet food in 1.5 kilogram packs. Her pet needs 0.8 kilograms of food per week. She wants to have enough food for the next 14 weeks. She already has two 1.5 kilogram packs. Work out the smallest number of packs she needs to buy. You must show your working. Okay. Right, so I think what we need to do is work out exactly how much pet food it needs, and then we can work out how many packs we need, and we can then subtract what we've already got. Okay, something along those lines. So let's work out the amount of food required first. So food required is going to be it needs 0.8 kilograms per week, and we want it for 14 weeks, so it's going to be 0.8 times 14. What's that then? So 0.8 that's 11.2 kilograms of food over the 14 weeks. Okay, so we know that pet food comes in 1.5 kilogram packs. So if we need 11.2 kilograms, then the number of packs required then, number of packs, that's going to be 11.2 kilograms of food we require divided by the pack size of 1.5 kilos, and that comes out to be 11.2 divided by 1.5, that comes out to be 7.46 and change. I'm going to round that off to 7.5. 7.5 packs. Now remember, well, so that's roughly, we can't buy 7.5 packs, so if we wanted 7.5 packs, you have to actually buy 8 packs, wouldn't we? Okay, remember we've got 2, we've already got 2, haven't we? So less 2 in hand, so minus 2 from there, that's going to give me 6 packs required then, isn't it? So that's my answer, 6 packs. Question 19, it says a scale drawing shows the positions of P, Q and R. Okay, now it does mention scale drawing, but don't be thinking these are drawn to scale, because they're not. It says not drawn accurately over here. So we've got an inaccurate drawing of a scale drawing. Weird. But anyway, so we're going to use the measurements rather underneath the numbers given rather than measuring things on the diagram. So on the scale drawing, the distance from P to Q is 4. I'm just going to add those in, okay, so I can see them in the diagram. So P to Q, that distance there, look, I know that be 4. I don't know why I did it in yellow. And Q to R, that, might as well go with the theme now. I'm going to go green this time. That is 6.5 centimeters, and the actual distance from P to Q is 50 meters. Less the actual distance QR. What? Oh, so the actual distance from P to Q is 50 meters or less than the actual distance from Q to R. Okay, so if I took my Q to R line, which I know is 6.5, okay, and I compared it with my P to Q line, which I know is 4, then the difference between them, this amount here, on the scale or in reality is 50 meters. Okay, does that make sense? Okay, so the actual distance from P to Q is 50 meters less than the actual distance from Q to R. So this was QR and this is PQ. Okay, So you get the idea. So anyway, so if I look at the difference between these two lines, so one is length 6.5 and then the other one is 4. So then this distance here in the scale drawing is going to be 6.5 minus 4. That's going to be 2.5 centimeters. So that's 2.5 centimeters, and that goes with my 50 meters. So 2.5 centimeters goes with my 50 meters. That's kind of the beginnings of a scale, isn't it? But the units have to be the same. So I can't have centimeters and meters. So and also it's probably good to have one of these numbers being a 1. Okay, so the first thing I'm going to do is going to divide both sides by 2.5, I think. So 2.5 divided by 2.5 is 1. So it's 1 centimeter to and then 50 divided by 2.5 should be 20. So 1 centimeter goes with 20 meters. So, and if you remember, there are 100 centimeters in a meter. So actually that scale is 1 to 20 times 100. It's going to be that then, isn't it? It's the scale then is going to be 1 to 2000. That's my answer, 1 to 2000. Now I think my working went a little bit off. I'm just going to pull it this way a little bit. So the diagrams I was drawing earlier, I just realized were slightly off the page. Naughty me. So this is the bit I was saying was 2.5 and 50, the difference between Q to R and P to Q. Hopefully that is clear. Well, I just realized, I just scrolled down a little bit more and I realized actually the answers are a whole lot easier than I first said, because it says 1 centimeter represents, it's going to be 20 meters, isn't it? Now I did a proper scale ratio here, 1 to 2000. That's probably what you'd actually see on a map. But they want just 1 centimeter represents 20 meters. So this last step that I did, a little bit superfluous, but anyway. Question 28. A and B are whole numbers. Work out the largest possible value of 2a plus b. Well, the largest possible value of 2a plus b, that's going to be largest when a is the largest possible value it can be, and b is the largest possible value it can be. Now we've got two inequalities up here. It says a is less than or equal to 12. So the largest whole number a can be is 12 then, isn't it? So 12, I can use 12 as my largest value of a. But with b, I've got b is strictly less than 9. So the largest whole number that b can be is actually 8, not 9. Okay, so a little bit tricksy, that one. Okay, so that's going to be the largest possible value is b is 8 and the largest possible value of a is 12. So the largest possible value of 2a plus b is going to be 2 lots of 12 plus 8 then, isn't it? Okay, 2 12s are 24 plus 8 is 32. Okay, so it's going to be 32. Okay, and then part B says x and y are both negative numbers. Show that y divided by x could be equal to 4. Okay, well, if they're both negative, we know that a negative divided by a negative is positive. We just need to find one example where we can get this to work. Okay, so as long as y is 4 times bigger than x, if we divide y by x, we should get 4, shouldn't we? So let's say y was 8. Well, it has to be minus 8, doesn't it? And x was negative 2. Then negative 8 divided by negative 2, that's going to give me 4, isn't it? So then y divided by x equals minus 8 divided by minus 2, which is equal to 4. Okay, so I've shown it. I've taken I've taken an example of values of y and x. I've shown the maths and I showed it can be equal to 4. Okay. Question 21. Jill puts 440 sweets into small bags, medium bags, and large bags. Now, the small bags hold 8 sweets, the medium holds 12, and the large holds 16. Now, she uses 30 small bags, twice as many medium bags as large bags, and there are no bags left over. There are no sweets left over, sorry. Okay. So I'm just going to write that information under here. So the number of small bags you use, that's going to be 30. Now I don't know how many medium bags we use, but we know it's twice as many as the large bags. Now when we don't know something in maths, best thing to do is to find, or to give it an algebraic value then. So if I say that large bag is x, okay, so then the medium bags is going to be twice as many as the large bag, so that's going to be 2 lots of x. 2 lots of x. So I've got 30 bags and 2x bags and x bags. So how many bags is that altogether? Do I need to know that? No, that's not going to help me. Okay, so let's just, well, it might help me in a minute. Let's see. Let's do the small sweets first. If I got 30 bags of the small sweets, how many sweets is that altogether? So 30 times 8. That is going to be 3 8s are 24. That's 240 sweets gone already. Okay, so remember we had 440 to start with, and now I've used 240 in the small bags. I could barely read that. Let me just write that down again. 240 sweets in the small bag. Okay, so that leaves me with 200 sweets to fit into these other 2 bags. Okay, now the medium bags, if I've got 2x bags and each bag contains 12 sweets, I'm going to do the same thing as I did with the small bags. With the small bags, I took the number of bags and I multiplied it by the number of sweets, and I got the total number of sweets in those bags, didn't I? Okay, and that came out to be 240. Now I'm going to do the same thing here. I'm going to take the number of bags, 2x, and I'm going to multiply it by the number of sweets, 12, and I'm going to get the total sweets in those bags. So 2x times 12, what's 2x times 12? That's going to be 24x. So I've got 24x sweets in the medium bag, and I'm going to do the same thing with the large bag. If I've got x sweets in there, and I've got 16 sweets, sorry, x bags, and I've got 16 sweets in each bag, then altogether I have got x times 16, which is 16x sweets. So I've got 24x sweets in the medium bags, and I've got 16x sweets in the larger bag. So altogether, that's 24x plus 16x. In the medium and the large bags altogether, I've got 24x and 16x together. So 24x plus 16x. That gives me a total of 40x sweets in those 2 bags. Now, I just worked out earlier that I had 200 sweets left in those 2 big bags. So that means that 40x, the number of sweets in the small, medium and the large bag, is equal to 200. Okay, so from that we should be able to work out x, the number of bags. If I just divide both sides by 40, that's going to cancel with that. It's going to leave me with x, isn't it? So 200 divided by 40, 20 divided by 4, that's 5. Okay, so that means there must have been 5 large bags, because x is 5, and that means I must have had 2 lots of 5. I should have had 10 medium bags. Okay, so what do we actually need to do here? So I've worked out how many bags. So for the number of bags, work out the ratio of small bags to medium bags to large bags. So that means the ratio then is 30 to 10 to 5, which is lovely, but it's not in its lowest term, isn't it? Because they're all divisible by 5. So dividing each one of those by 5, then they're in the ratio of 6 to 2 to 1. Okay, that's my final answer, 6 to 2 to 1. Quite a tricksy question, that one. Question 22. Here is the graph of y equals x squared minus 7x plus 10 for values of x between 0 and 7. Okay. So question 22a says write down the roots of x squared minus 7x plus 10 is equal to 0. Basically what it's doing here, when we're asking to find the roots, or we're given an equation that's equal to 0, y is equal to 0 is actually this line here. It's the x-axis. So what you're being asked when you're asked to find the roots is you're asked to find the values where the curve passes through the x-axis here. So you can see it passes through in two places. So the roots of that equation is going to be x is equal to 2, okay, that's the one on the left, and x is equal to 5, okay. Write down the x-coordinate of the turning point of the graph. Now the turning point is the bit where it stops going down and starts going up, which is that point there. Now you can see this is what we call a parabola, this shaped curve. It's a quadratic curve, and quadratic curves are symmetrical around that middle line there, okay? And because they're symmetrical, it means that midpoint then is going to be halfway between my 2 and my 5. I know that point there matches with that point there. The 2 matches with the 5. Didn't want to undo that. So it's going to be halfway between the 2. So what lies halfway between 2 and 5? Well, it's going to be 3.5. You can just read it off the scale there, can't you? So it's going to be 3.5. So we just need to write down the x-coordinate here. So x is equal to 3.5 is my answer.
Advertisement break. Hopefully you are able to use this past paper to identify any topics that you still need to focus on for your exams. It's best if you do some focused revision around these topics between past papers, and this series of videos will help you do just that. They are based on the AQA topic tests, including key topics like trigonometry, surds, indices, and a whole lot more. Click on the card above to go to the playlist. I'm adding to this collection all of the time, so if the topic is you're looking for is not yet covered, it soon will be. So subscribe below to make sure you don't miss out on any of these uploads. Right, back to the maths.
The time spent watching TV was recorded. The table shows the average time per student each year from 2012 to 2019. A time series graph is drawn to represent the data. The first 4 points have been plotted, and part A says complete the graph. So 2012 has been plotted at 157, so like this point here has been plotted, it's that one there. And then we've got 2013, which has been plotted here at 148. And then I've got 2014 that's been plotted here. And I've got 2015 that's already been plotted here. So I need to plot 2016 up to 19 onto the graph. Okay, so if you have a look at the scale is going up in tens, and I've got 5 divisions between each main scale point. So between 60 and 70 you've got 5 little squares, so each one of those must be 2. Okay, so 2016 on my scale, I've got to put a mark at 113. So I'm going to come up like 1.5 little squares above 110 to mark 113. So it's going to be there. Okay, and then the next one along 2017 is at 100. That should be fairly easy to plot. It's just on the whole line. Then 2018 is at 90. Again, very simple to plot that one. And then finally 2019 is at 82. So that's going to be 1 little square above 80 then, isn't it? It's going to be there. Okay. Once you've done that, let's just join them up with straight lines. Okay. It says use your graph to estimate the average daily time per student in 2020. Okay, so I'm going to assume that this is kind of falling linearly. It's kind of not quite linear, is it? Kind of bibbles around a little bit, but a bit like a line of best fit. I'm going to draw a line through those points as best I can, and I'm going to use that to estimate what it is at 220, or 2020, sorry. So 2020 would be the next unit up on the scale here, wouldn't it? 2020. So taking my ruler, read it up to the curve. And then along. That seems to be around about 71, 72. Okay, I'm going to write down 72, I think. So 72 is my estimate. But again, if you do your graph slightly differently, you're going to get a little bit of leeway on that. So just check your graph, read across like I have, and read off your number as best you can. Let's work out the highest common factor, HCF of 75 and 105. You've got different approaches for doing this. Either you can find all the factors of 75 and 105, and then find which one is biggest on both. So what goes into 75? 1 goes into it, and 75. 2, no. 3, yeah, 3 goes in, and 25. 4, no. 5 does though. 5 and 15. 6, nope, don't think so. 7, nope. 8, nope. 9, nope. 10, nope. 11, nope. 12, nope. 13, nope. 14, nope. And then I've kind of met myself coming back down the other way. Now I could do the same thing with 105. 1 and 105. 2, no. 3, yeah, 3 goes into 105, doesn't it? It goes in 35 times. 35, 90, yeah, 35 times. 4, nope. 5, yes. 5 goes in 21 times. 6, nope. 7, yes, 7 does. 7 goes in 15 times, doesn't it? 7 15s. 8, nope. 9, nope. 10, nope. 11, nope. 12, nope. 13, nope. Okay, so it's just I've kind of met myself coming back down the other way again there. So there are all the factors of 105 and 75. The common factors are 1, 3, 5, 15, and that's it, isn't it? Yeah. So the highest common factor then is going to be the biggest one in that list. It's 15. Okay. So it's 15. So you could do it that way. There is an alternative approach using prime factor decomposition. If you type into your calculator 75 and equals, and then press shift fact, it will rewrite your number in what we call prime. It's product of prime factors. So 75 is equal to 3 times 5 squared, or 3 times 5 times 5, and 105, I'll do the same thing. 105 shift fact gives me 3 times 5 times 7. So basically what you do is you see what are on both lists. So I've got 3 on both lists, and I've got a 5 on both lists. So then the HCF is made up of 3 and 5, which is 15. So probably this method here is the quickest in this situation. Rather, it took me a bit longer to find all the different factors, and there is a danger of, when I find all the different factors, especially if the number is large, that I miss one out. Okay, so I might actually miss a pair, or don't realize one divides by another. In exam pressure, it's possible. So you know, if you can master this method might be quicker and more reliable in the exam. Okay, right, let's move on. Here's a cuboid. Assume that the total surface area of the cuboid is 200 square centimeters. Work out the volume of the cuboid. Okay, well, the total surface area is going to be made up of the areas of the 6 faces of your cuboid. Okay, so I've got 2 identical faces here and here, haven't I? They're both going to be 5 times 5. Okay, so I'm going to get 5 times 5, and I'm going to have 2 of those. Okay, and then I'm going to have the top and the bottom. Now that is going to have a side of 5 and y. So if I multiply those together, I'm going to get 5y. Okay, so I've got 5y for the top and 5y for the bottom. So I've got 2 of those, isn't it? I've got 5y times 2. What about the front and the back face? Now again, the front and the back, this face here and the back one, okay, are going to be 5 times y again. So I'm going to have 5y for the front face and another 5y for the back face. Okay, so what's that all together then? So 5 times 5 times 2, 5 times 5 is 25, times 2 is 50. 5y times 2 is 10y. 5y times 2 is 10y. So adding all that up, I'm going to get 20y plus 50. Now I'm told that the total surface area of the cuboid is 200. Okay, so that means that 20y plus 50 must be equal to 200. Okay, so subtract 50 from both sides. That's going to tell me that 20y is equal to 150, and then dividing both sides by 20 then. That's going to tell me this cancels with this, leaving me with y equals 15 over 2, 7.5. Okay, so that's the length y is 7.5. So then the volume of the cuboid is length times width times height, which is 5 times 5 times 7.5. So reaching for the calculator because I'm feeling a bit lazy. 5 times 5 times 7.5. That comes out to be 187.5. Okay, 187.5 cubic centimeters. Part B says, in fact, the total surface area of the cuboid is smaller than 200 centimeters squared. What does this mean about the volume of the cuboid? Tick one box. Okay, so if you remember, we had the formula 20y plus 50 equals 200 to work out y. Now, if 200 is not 200, but it's smaller than 200, that must mean that when we found that 20y is equal to 150, if 200 was smaller and I took 50 away from it, I'm going to have an even smaller number here, which means that y must have been smaller than 7.5 then. Okay, so it's not 7.5, it's smaller than 7.5. So then the volume, which was 5 times 5 times y is going to be smaller than it was. So then we multiply those three things together, the volume is going to be smaller than it was. Okay, so it is smaller than the answer to part A. Question 26. Here is some information about the time spent on social media by 50 people. It's usually far too much these days, isn't it? Admit it. Get off TikTok. Circle the number of people who spent more than 30 minutes. Okay, so then more than 30 minutes. So we've got 0 to 15 minutes, so not that group there then. So not that one. 15 to 30, no, they're all good. It's these other people who spent far too much time on it down here. Look, it's going to be these. These are 30 to 45 and 45 to 60. So those 31 plus 8 people, that's 39 people altogether. It's that one there. At a party, there are 90 people. 48 are women and 42 are men. Some women leave. Some men arrive. The ratio of women to men is now 10 to 11. Are there now more than 90 people at the party? And I can either say yes, no, or cannot tell. Okay, so let's think this through. So there are 90 people at the party, 48 women and 42 to men. So at the start of the party, the ratio of women to men is 48 to 42. Okay, now some women leave, so this number here is going to go down, and some men arrive, and this number here then is going to go up, and the new ratio is going to be 10 to 11. Okay, now can I make a kind of equivalent ratio out of 10 to 11 that accommodates that situation up there? Okay, now let's just think of all the multiples of the ratio 10 to 11, all the equivalent ratios. So if I multiplied both parts by 2, for instance, the ratio would be 20 to 22. If I multiplied it by 3, I would get 30 to 33. And if I multiplied it by 4, I'm going to get 40 to 44. Okay, so is there any other possibility? Now if I multiply it again, I'm going to get 50 to 55. Now just think, let's have a think about which one of these ratios actually could work with the numbers 48, less than 48 and more than 42. Okay, the first one, 10 to 11, 10 is less than 48 but it's not more than 42, so it's not that one. Okay, 20 to 22, 20 is less than 48, 22 is less than 42, so that one doesn't work. 30 to 33 doesn't work. This one does work though, isn't it? Because if 8 women left and 2 men arrived, then this one could work, couldn't it? It could be 40 to 44. And then what about the other one, 50 to 55? That one doesn't work again, does it? Because then there are too many women. That means the number of women would have gone up rather than down. Okay, so there's only one possible scenario it could be. It must be that there are 40 women and 44 men. Okay, so if there are 40 women and 44 men, then the total number of people at the party is going to be 40 plus 44, which is 84. Okay, so are there now more than 90 people at the party? No, there are not, because there are 84. Okay, Alex and Bev sat 6 tests, each with 50 marks. The table shows their mean percentages after 5 tests. So Alex is on 60 and Bev is on 52%. After all 6 tests, their mean percentages are equal. In the 6th test, Alex scored 24 out of 50. Work out Bev's score out of 50 in the 6th test. Okay, so they did 6 tests, but the mean of that we've been given here is the mean for 5 tests. So this is what the mean score that Alex got in 5 tests. So on average, in those 5 tests, he scored 60%. So altogether in those 5 tests, if I take 60 and I multiply it by 5, he scored 300% in all 5 tests added together. Whereas Bev scored 52 times 5, which is what, that's 260%, isn't it? Okay, so she scored 260% in those 5 tests. Now in the 6th test, Alex scored 24 out of 50, didn't he? So that as a percentage is just double 24 and 50. You're going to get 48 over 100, so that's 48%. So adding that onto his 5 tests means that in total over the 6 tests, Alex got 348% in total. Okay, so then if Bev is going to move from 260% up to 348%, she's got a lot to do, isn't she? She's going to have to add on another 88% then there, isn't it? So 260 plus 88 would take you to 348. Okay, so that means that Bev So that means Bev would score 88% in final test, but it wants it as a score out of 50, annoyingly. Okay, so then we're going to have to convert that back then. So if she got 88%, then that is going to be 44 out of 50 then, isn't it? Okay, so that's her final answer, 44 out of 50. A solid piece of silver has mass of 2.625 kilograms and a volume of 250 cubic centimeters. Work out the density of silver. Give your answer in grams per cubic centimeter. Okay, so the formula for density is mass divided by volume. Okay, so subbing in our mass, we just need to make sure we've got the right matching units. Now the answer is looking for grams per cubic centimeter. Okay, so our volume's already in centimeters, so that's fine. But this up here is in kilograms, isn't it? Okay, so we need to convert this into grams before we sub it into the equation. Now there are 1,000 grams in 1 kilogram, aren't there? So 1 kg equals 1,000 grams. So if I multiply 2.625 by 1,000, I will convert it from kilograms into grams. So that is 2,625 grams. Okay, so then sub in my newly converted mass into the formula. I'm going to get 2,625 divided by my volume of 250. So what's that then? 2,625 divided by 250. That comes out to be 10.5. So it's going to be 10.5 grams per cubic centimeter. Work out the gradient of the straight line through -2, 3 and 1, 9. Okay, now there's a handy formula for working out the gradient. It is gradient is equal to y2 minus y1 over x2 minus x1. Okay, so what are y2, y1, x2, x1? Well, the first coordinate there has values x1, y1, and the second coordinate has values x2, y2. So y2 then is going to be that second value there, it's going to be the 9. y1 is going to be that value there, which is the 3. And then x2 is going to be that value, which is the 1. And x1 is going to be that value, which is the -2. So subbing those carefully in, y2 is 9 minus y1, which is 3, divided by x2, which is 1 minus -2 for x1. Okay, so I've got 9 minus 3 over 1 minus -2. Okay, well 9 minus 3 is 6. 1 minus -2, 1 minus negative, same as adding, it's 1 plus 2, that's 3, 6, 3, that's 6 divided by 3, gives me a gradient of 2. Gradient is 2.
So that's all, we've reached the end of the paper. How did you do? Let me know in the comments below, along with any questions you still might have. Don't forget to like and subscribe if you found this walkthrough helpful. If you didn't do so well, try revising around the topics you're struggling with before attempting another past paper. Good luck with your preparations and in your exams, and see you again next time.